Hey guys, welcome to CPM 3. We are starting Module 4, so here's your first lesson. It is over solving system of linear equations by graphing. So you're starting off with two definitions. I've already wrote in the blanks. It says a system of linear equation consists of two or more linear equations. And then your second definition is a solution. A solution of a system of two equations and two variables is an ordered pair of the numbers that is a solution or satisfies both equations in the system. So, keyword here is that it does have to satisfy both, not just one or the other. So, for example here, determine whether 12, 6 is a solution of the system. So, this is, let me change colors. This is your X and this is your Y. And so first, take the first equation here and plug that in for both of them. So now we have 2 times X, which my X is 12, minus 3 times Y, and your Y is 6. And I want to know, does that equal the other side of this equation? Does that equal 6? So multiply these out. 2 times 12 is 48. Nope, that'd be 24. Minus 3 times 6 is 18. Bring down your equals 6. And you can stop it here if you can see that, yes, 24 minus 18 does equal 6, or you can bring it down to 6 equals 6. Now, you cannot stop and say that this is a solution. You have to make sure it satisfies both of these. So now I'm going to take this bottom one and plug this in as well. So I've got X equals, and X is my 12. And I want to know, does that equal my 2Y, and my Y is 6? So 2 times 6. And again, if you can see that 2 times 6 is 12, we can stop right there. Or you can bring it down to the next line and say 12 does equal 12. Okay, but either way, because it satisfies both equations, we can say that yes, 12, 6 is a solution. Okay, let's try this next one. It says determine whether -1, 2 is a solution of the system. So do the exact same thing. -1 is my X, 2 is my Y. So take this first equation, and we've got -1 plus 2 times Y, and my Y is 2. We have to figure out, does that equal 3? So we'll have -1 plus 2 times 2 is 4. And if you know that -1 plus 4 is 3, then we're good. Or we can bring it down and say that 3 equals 3. Again, we cannot stop right there. You have to check it into the next one. So I've got 4 times my X, which is -1, minus Y. And I got to figure out, does that equal 6? So 4 times -1 is -6. Sorry, 4 times 1 is -4. And -4 minus 2 is -6. We got -6 equals 6. I'm going to put a little slash to that equal sign because that is not equal. And so, because I plugged it into 1 and it does not work, it does not matter that it worked on this first one because it did not work for at least one of them. So we will say no, -1, 2 is not a solution. Okay, and that's why it's really important you plug it into both. Now, if I plugged it into this one first and I got a no from the beginning, I don't need to plug it into the second one. If it doesn't work for one, it doesn't matter if it works for the next one. But when you plug it in and it works for the first one, you have to make sure it works for the second one as well. But once you get a no, you can stop. Okay, so now let's get to the majority of this right here, which is we said we're going to solve this by graphing. So this says, since a solution of a system of equations is a solution common to both equations, it is also a common point to the graphs of both equations. So, to find the solution of a system of two linear equations, we graph the equations and see where the points intersect. A helpful hint says neatly drawn lines can help when guessing the solution of a system of linear equations by graphing. So the more neat these lines are, you don't have to guess which one it is. Basically, when we graph these lines, I want something that crosses, but see how like this right here, it doesn't really quite cross at that point. It crosses a little bit above it. And so then in that case, I'm going to have to guess. Okay, so it's better for you to make these nice and neat. So we went over graphing in Module 2. We've got to graph again. So in my first equation here, these are both nice because these are both in your y equals mx plus b form. So they tell you the slope and they tell you that y-intercept. So in this first equation, y equals x minus 2. My slope is whatever in front of this x. In this case, it's 1. And we do need that as a fraction. So that would be 1 over 1. That way I know my rise over run. And then my y-intercept is whatever that b part. In this case, it's negative 2. Okay, so let's try graphing this. So I'm going to start at my y-intercept of negative 2. And what I'm going to do when I use this rise over run, we're going up 1 over 1, then up 1 over 1. We said before that all you need to graph these are 3 lines. But I'm actually going to keep rising and running throughout this whole thing. I want to actually just rise and run until my dots intersect with the other dots. So I rose 1, ran 1 as far as I could going up. Now I'm going to go down 1, over 1, down 1, over 1. And go in the opposite direction. Okay, so here is my first line. So now, my second equation is y equals 2x plus 3. So now, my slope is 2, and again, I need that as a fraction. So that is 2 over 1. And then my y-intercept is whatever is at the end of this, so in this case 3. So I'm going to start at my y is 3. Oh, I don't know why that does that. It irritates me. Ugh. Sorry guys, having some technical difficulties. Okay. And now, because my slope is 2 over 1, that means I'm going up 2, running 1. So up 2, running 1, up 2, running 1. And I went as far as I could that way, so I'm going to go the opposite way. And hopefully when I go now down 2 over 1, down 2 over 1, down 2 over 1, hopefully we land on one of these dots that we have for this line exactly. So down 2 over 1, down 2 over 1, over 1, down 2 over 1, down 2 over 1. So that very, very last point in this graph. So I'm going to go ahead, and I don't know why this one looks like that now, but that's supposed to be a dot. I'm going to go ahead and connect those lines. Okay. And so now, when I solve this, whatever this ordered pair is on where they cross, that is my final answer. So, when you write your ordered pair, when you use your slope, you rise over run, right? So you go up or down first, then left or right. When you have an ordered pair, it is X comma Y. You got to remember your OU. So from this origin, it's how many am I going left or right, then up or down. We're moving in opposite directions here. So this is negative 1, 2, 3, 4, 5 on my X. And then from here, we're going 1, 2, 3, 4, 5, 6, 7 down. So this is my final answer. All right, let's try again. Now, as much as you might not have liked A, it was actually very nice to us because it was in my y equals mx plus b. This is not in my y equals mx plus b. So I'm going to take this first one here, and I need to solve this for y. It's the same steps every time. You need to move your x term over. So in this case, because it's a positive 4x, I'm subtracting my 4x over. So I'm going to be left with negative 2y equals, I can't combine these, so negative 4x plus 12. And then I'm going to divide everything by negative 2. So we get y equals negative 4 over negative 2 is 2. And 12 divided by negative 2 is a negative 6. Okay, so out of this, now my slope is 2, which is 2 over 1. And my y-intercept is negative 6. So I'm going to start on this negative 1, 2, 3, 4, 5, 6. For my y-intercept. Okay, then rise 2, run 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Just keep going throughout this whole thing. Okay. So here is eek. And then my next one is y equals 2. If you're unfamiliar, if that goes horizontal or vertical, you can make a little chart. We know that y is always going to be 2, and so we can just put in any numbers we want for our x. But you're going to go along your y-axis here to 2. Oh, so annoying. Two, 2. If you're making the 3 points, it's 1, 2, 3 right there. And then that is your horizontal line. So on this one, where do these two lines cross? Right here. And so what is that ordered pair? So remember OU. So from the origin, we're going over 1, 2, 3, 4. And then from there, we're going up 1, 2. that is my final answer. Your final answer is where these two lines intersect each other. Okay. Down here, we're going to finish this page with some definitions. So it says a system that has at least one solution, like both of these in example 3, this is known to be consistent. Okay, so if it has at least one solution, if it crosses somewhere, then it is consistent. Also, it says if the graphs of the equations are different, again, like both of these in example 3, the equations are independent. So if you don't have different lines, they're dependent, and if they don't have one solution, they're inconsistent. So let's look at what those look like on the next page. So more times than not, you're going to get this right here where your two lines cross at one spot. And so we just discussed that means it's consistent because it has a solution, and it's independent because it's different lines. There's two other things that can happen. They're more rare, but they can happen. So here's the first thing. Second thing that's going to happen is that you're going to have parallel lines, and you are going to have no solution. Okay, no solution. So this one is considered inconsistent because it has no solution, but they are still two separate lines, so it's still an independent equation. The third thing that can happen is that you have infinite number of solutions. So because I have an infinite amount, because it is at least one, it is consistent. But now you have the same line directly on the same line. So now this is considered a dependent equation because you don't have different lines. Okay? And because you have the same line on top of the same line, the reason this has independent or infinite solutions is all of those are points. Okay? So let's graph these. You're going to get one of each. So example 4 says solve each system of linear equations by graphing. So this first one here, we've got 2x plus y equals 0. This is not in slope-intercept form. So I need to solve this for y. So I'm going to move my x term over. So I've got y equals negative 2x. If you want to put a plus 0 here, you can, but it's not necessary. So now here, my slope is negative 2, which is the same as negative 2 over 1. And my y-intercept is at 0 since we don't have anything there. So here at 0, now we're going to go up 1. Nope. We'll go, since it's negative 2 over 1, we'll go down 2 over 1. So down 2 over 1, down 2 over 1, and just keep going. Okay, now I went all the way I could that way. So now let's switch that sign and make that 2 over negative 1. So now from this point, I'm going to go up 2 and run a negative 1. Up 2, run a negative 1. All right, so there's my graph. Okay, let's now take this second one. And I'm going to go ahead and switch these right here because we want this in y equals mx plus b form. So this is 2y equals negative 4x plus 6. Notice when I switch it, this 6 needs to stay positive, that 4x needs to stay negative. So here all I'm doing is dividing everything by 2. So we've got y equals negative 4 divided by 2 is negative 2x. And 6 divided by 3, or sorry, 6 divided by 2 is 3. So now my slope is negative 2, which is negative 2 over 1. And my y-intercept is 3. So we'll start at 1, 2, 3. Oh, gosh. We'll start at 3. And do the same rise over run. So down 2 over 1, down 2 over 1, down 2 over 1, and just keep on going. Okay, now we went as far as we could one way. So let's switch our negative and make this a 2 over negative 1. So now I'm going to go up 2 over 1, up 2 over 1. Okay, so my second line is right here. So on this one, what do we have? This is our example 2 right here where they're parallel lines. If you notice, because their slopes are the same, they're rising and running at the exact same rate, so they're never going to intersect with each other. So this one here is a no solution. So I'm sure you can guess what this next one's going to be. All right, so neither of these in slope-intercept form. So I'm going to take this first one and solve it for y. Now, my y and my x is backwards, but that's okay since I'm going to be rearranging it anyways. So you always move that x term first. So negative 4x plus 6. Divide everything by 6. So I've got y equals, I can't, this is going to be a fraction. I can simplify. I can divide them both by 2. That's going to be negative 2 over 3x. 6 divided by 6 is 1. Okay, so here my slope is negative 2 over 3, and my y-intercept is 1. So we'll start at my y-intercept of 1. Because it's negative 2 over a positive 3, we're going to go down 2, run 3, down 2, run 3. Okay, can't go any more that way, so I'll switch that negative. We're going to go up 2 and then to a negative 3. So up 2, negative 3, up 2, negative 3. So here is my line. And now let's take this equation here and solve it for y. So 3y minus 3 equals negative 2x. Want to get that y by itself, so we're going to add the 3 over. Those are unlike terms, so they're just going to go side by side. Now I'm going to divide everything by 3. So I can't reduce that, so we've got negative 2 over 3x. 3 divided by 3 is 1. So what's my slope? Negative 2 over 3. And what's my y-intercept? 1. So if you notice here, they're the exact same, right? We've got a y-intercept at 1, down 2 over 3, down 2 over 3. And then if we switch that and make that 2 over negative 3, now we're going up 2 over 3, up 2 over 3. So here, I have the exact same line on the exact same line. So not only are those 5 points a solution, all of these little things here in the middle are all solutions too. So this one is our example 3, when we have the same line and we have infinite solutions. So those are our 2 special cases that we can get with this. All right. And now if you'll turn that page, we've got one more thing to go over. It says here, you can determine how many solutions a system has by writing each equation in slope-intercept form. So your slope-intercept form sorry, I'm being a little OCD right here. Okay. This is your y equals mx plus b form. And then you can determine by looking at the slope's line and y-intercept. So if you kind of look over here on this previous page, we knew that these were going to be parallel because they had the same slope but different y-intercepts. On B, I knew this was infinite solutions because we had the exact same equation. So once I put it in this y equals mx plus b form, it has one solution if the slope is different. If the slope is different, this y-intercept doesn't matter. Okay, and what I mean by it doesn't matter, it can be the same or different. If my slopes are different, I have a solution. Second thing that can happen is I get no solution, and we get no solution if the slope is the same. And if the slope is the same, but the y-intercept is different, that's parallel lines, we've got no solution. And then lastly, what can happen if we have infinite number of solutions, everything is the same. Okay, those are the 3 things that can happen here. So on example 5, without graphing, determine the number of solutions in the system. So here, this one, if I take this one here, we've got 3x plus y equals 1. Solve it for y. So I'm going to subtract my 3x over. I can't combine, so that's negative 3x plus 1. I'm going to take this next one, that bottom one, solve it for y. So we're subtracting that 3x over again. I've got 2y equals negative 3x plus 6 because I can't simplify, they're unlike terms. Divide everything by 2. And I get y equals, can't reduce anything there, so negative 3 over 2x plus 3. Okay, so the first thing you want to do is look at those slopes. Because your slope is negative 3 here and negative 3 over 2 there, as long as that slope is different, then you have one solution. Okay, let's try again. Now, take this one, that top one, solve it for y. So I've got 3x plus y equals 0. Subtract your 3x. So I've got y equals negative 3x. Take this bottom one here and solve it. So we've got 2y equals negative 6x. Get y by itself by dividing by negative 2. So I've got y equals negative 3x. Because this one is the same, exact same on both of these, this one is your infinite solutions. Okay, and my math lab may show you the symbol for infinity, which is that side words 8 that we used when we were doing domain and range, as well as graphing inequalities. And last one here, surely you know what the example of this one is. I'm going to take this first one, solve it for y. So I've got 2x plus y equals 0. Subtract your 2x over. So I've got y equals negative 2x. This one, how sweet is that, is already in slope-intercept form. Now this one has the same slope, but different y-intercepts. Because they have the same slope, but different y-intercepts, these are your parallel lines, right? They're rising and running at the same rate, but they're starting in different places. So this one is your no solution. And again, my math lab may use the symbol for that, which is a 0 with a slash through it. That means it's an empty set. Okay, that's still bad. So that is all I have for this lesson. There's two other ways to solve systems of equations, so 3 ways total. Next lesson, we're going to learn how to do this stuff algebraically without graphing. But that's all I got for this lesson. As always, pause this video and rewind it and let me know if you have any questions.